What if the story you were taught about human history is not the beginning at all, but the aftermath? What if everything we call civilization is what survived, not what first existed? Beneath the familiar timeline of stone tools, farming villages, and gradual progress lies a darker possibility: that an entire chapter of human experience was erased so completely that only shadows remain, embedded in myth, stone, and the silence between archaeological layers. Across the world, cultures separated by oceans remember the same thing in different voices. They speak of fire falling from the sky, of oceans swallowing land, of cold arriving suddenly and without mercy. These are not isolated legends, but fragments of a shared trauma, distorted by time, yet stubbornly consistent in their core message. Something happened at the end of the last ice age that did more than change the climate. It broke continuity. It reset the human story. The monuments that appear too early, the knowledge that seems to arrive too fast, the sudden gaps where development should be slow and messy, all of these hint at inheritance rather than invention. Not proof, not fantasy, but a question history has never fully confronted. Who were we before the world changed, and what was lost when it did? Before we dive deeper, ignite that like button and prepare for the revelations to come. Tell me in the comments where you are listening from, what time it is there. And as always with our videos, the visuals are here to add context, but they aren't necessary to follow along. Thank you for always having our back. Prepare yourself, and let's dive in. For most of its existence, humanity lived inside a world defined by ice. Vast glaciers covered entire continents, pressing down on the land with a weight so immense it reshaped the crust itself. Sea levels were far lower than today, exposing wide coastal plains where rivers wandered slowly toward distant shorelines. What are now shallow seas were once habitable landscapes, crossed by animals and people who had no concept that the ground beneath their feet would someday vanish. This was not a marginal phase of human existence. It was the dominant condition under which our species evolved, adapted, and survived. The last ice age was not a single frozen moment, but a long, unstable era marked by pulses of cold and warmth. Over tens of thousands of years, glaciers advanced and retreated like living things, responding to subtle changes in Earth's orbit and tilt. These slow celestial rhythms determined how much sunlight reached the northern continents during summer, controlling whether ice melted or endured. When summers were weak, ice sheets grew thicker and spread outward. When summers strengthened, they pulled back, releasing meltwater into rivers and seas. This gradual pattern shaped ecosystems, migration routes, and the very possibilities of human life. During these millennia, human communities adapted with remarkable flexibility. They followed animal herds across open steppe, hunted large mammals that no longer exist, and learned to read landscapes that shifted with the seasons. Their tools were simple by modern standards, but effective, refined through countless generations of trial and memory. Caves, temporary shelters, and open camps left faint traces that archaeology still struggles to recover. Yet these people were not passive survivors of a harsh world. They were active participants in it, building knowledge systems rooted in observation, memory, and shared experience. Then, near the end of this long frozen age, something changed with unusual speed. Around 12,800 years ago, as the climate appeared to be warming steadily, The planet abruptly lurched back toward cold. This interval, known as the Younger Dryas, interrupted what should have been a smooth transition into the present warm period. In regions across the northern hemisphere, temperatures dropped sharply. Glaciers that had been retreating stabilized or advanced again. Vegetation shifted. Animal populations were disrupted. For human groups already adapting to change, this sudden reversal would have felt like betrayal by the natural order itself. What makes this period stand out is not only the cold, but the violence of the transition. Geological records show signs of massive environmental stress compressed into a narrow window of time. Layers of sediment reveal widespread fires, abrupt changes in plant life, and disruptions in ecosystems that had taken thousands of years to establish. It is within this unstable window that many large Ice Age animals disappeared. Mammoths, mastodons, giant sloths, and other megafauna that had survived countless climatic swings were gone within a few centuries, sometimes far less. The disappearance of these animals mattered deeply to human survival. They were not just prey, but anchors of an entire way of life. Hunting strategies, seasonal movements, tools, and social organization had evolved around their presence. When they vanished, human communities lost more than food. They lost predictability. Landscapes that had once supported abundance became uncertain, forcing rapid adaptation under pressure. In such conditions, even small disruptions could cascade into cultural collapse. Evidence from Siberia adds to the sense that something unusual occurred. Frozen mammoth carcasses, preserved in permafrost, have been found with flesh, fur, and even undigested plants still intact. To the untrained eye, they appear to have died suddenly, caught in a rapid freeze. While modern science explains their preservation through a combination of cold, burial, and chance, the image itself is powerful. It suggests a world capable of changing faster than life could respond. A world where stability was an illusion. For generations, the Younger Dryas was explained primarily through changes in ocean circulation. As glaciers melted, enormous volumes of fresh water flowed into the North Atlantic. This influx may have disrupted a major system of currents that normally carries warm water northward. When that system weakened, cold conditions spread rapidly across Europe and North America. This explanation fits well with known physics and remains widely accepted. Yet it does not fully address the suddenness observed in some records, nor does it explain why signs of extreme disturbance appear nearly simultaneously across vast regions. Because of these unresolved questions, alternative ideas emerged. Some researchers proposed that the Younger Dryas was triggered not only by internal climate mechanisms, but by an external shock. According to this view, fragments of a comet or meteor entered Earth's atmosphere, exploding or impacting with enough force to ignite fires, destabilize ice sheets, and inject dust into the air. This dust would have reflected sunlight, causing rapid cooling. Supporters of this idea point to microscopic traces in sediment, tiny diamonds formed under extreme pressure, and unusual chemical signatures that resemble those found at known impact sites. Whether or not such an event occurred, the debate itself reveals something important. The end of the Ice Age was not a gentle handoff from one world to another. It was turbulent, unpredictable, and in places catastrophic. For people living through it, there was no sense of a long-term trend, no reassurance of gradual progress. There was only immediate survival in a landscape that no longer behaved as expected. Against this background, the question of lost human complexity becomes less abstract. If groups had developed stable traditions, specialized skills, or even early forms of social organization tied to Ice Age environments, those systems would have been extremely vulnerable to sudden disruption. Rising seas alone would have erased enormous stretches of coastal land, areas most favorable for settlement because they offered food, water, and transportation. As oceans climbed more than 100 meters over several thousand years, entire worlds were swallowed, taking their traces with them. What remains today is therefore incomplete by definition. Archaeology works mostly on land that stayed above water, on sites that survived erosion, flooding, and later human activity. The deeper past is filtered through loss. This does not prove that advanced civilizations existed before the Ice Age ended, but it does mean absence of evidence cannot be mistaken for evidence of absence. A record erased by ice, water, and time would leave exactly the kind of gaps that trouble our timelines. Seen this way, the end of the Ice Age becomes more than a climatic event. It becomes a boundary. On one side lies a long human story shaped by ice-dominated worlds. On the other lies the Holocene, the brief, warm interval in which agriculture, cities, and written history emerged. The transition between them was not clean. It was fractured. And within those fractures may lie explanations for why human history seems to restart so suddenly, as if something older had been forgotten rather than slowly invented. When the ice began its final retreat, the world did not simply warm, it transformed. Coastlines shifted inland year after year as meltwater poured from collapsing ice sheets into the oceans. Rivers changed course, valleys flooded, and plains that had once supported game and human movement disappeared beneath rising seas. For people living at the margins of these ancient coasts, the loss would not have felt gradual. A shoreline that moved a few meters each year would, within a single lifetime, erase familiar landmarks and ancestral grounds, turning memory into open water. During the height of the Ice Age, sea levels were more than 100 meters lower than they are today. This exposed enormous areas of land that no longer exist on modern maps. Continental shelves, now submerged, were once broad landscapes threaded with rivers, wetlands, and forests. These were not remote or marginal zones. They were among the most productive environments on Earth, offering fish, shellfish, birds, fresh water, and easy travel along natural corridors. It is in such places that human populations tend to concentrate, because survival requires less energy and risk. As the ice melted, these favorable regions were the first to vanish. Entire ecosystems were drowned, and with them any traces of human activity tied to those landscapes. Camps, shrines, burial grounds, and pathways were erased not by destruction, but by submersion. The sea does not leave ruins in the way earthquakes do. It covers, disperses, and preserves selectively, making later discovery difficult and expensive. This simple geological fact has enormous consequences for how we reconstruct the human past. One of the clearest examples of a lost landscape is Doggerland, the vast region that once connected Britain to mainland Europe. During the Ice Age, this was a living world of rivers, marshes, and open grasslands. People hunted, fished, and gathered there for thousands of years. Evidence of their presence surfaced only accidentally, pulled up by fishing nets in the North Sea. Bones of animals long extinct, stone tools shaped by human hands, and even fragments of human remains emerged from the depths, silent witnesses to a land that no longer exists. Modern technology has allowed scientists to map Doggerland's ancient river systems using seismic surveys originally designed for oil exploration. These maps reveal a complex terrain, not a barren plain, but a rich mosaic of habitats. When sea levels rose, this land did not vanish overnight. It fragmented into islands, then smaller refuges, before finally disappearing beneath the waves. For the people who lived there, each generation would have experienced loss, displacement, and the pressure to adapt to shrinking space. Eventually, a final blow may have come from the north. Around 6200 BC, a massive underwater landslide off the coast of Norway, known as the Storegga Slide, likely triggered a tsunami that swept across what remained of Doggerland. A wall of water moving faster than any human could escape would have erased the last habitable zones in minutes. Survivors would have fled inland, carrying memories of a world destroyed by the sea. Such experiences do not vanish quietly from cultural memory. They become stories. This pattern repeats across the globe. Wherever ancient coastlines existed, there is reason to suspect that human history lies underwater. Off the coast of India, near the modern city of Dwarka, underwater structures have been found that suggest an ancient harbor settlement. Stone anchors, walls, and foundations hint at organized construction. Local tradition speaks of a great city swallowed by the sea, its destruction tied to the end of an age. Archaeology struggles to pin down exact dates, but even the possibility that some remains could be thousands of years older than known urban centers challenges simple timelines. Farther east, near the Japanese island of Yonaguni, divers discovered massive stone formations beneath the water. Broad terraces, sharp angles, and step-like structures appear carved rather than eroded. Some researchers argue these shapes are natural, the result of geological fracturing and erosion. Others see patterns that resemble intentional design. The debate itself is revealing. If such structures were found on land, they would be investigated intensely. Underwater, they remain ambiguous, suspended between dismissal and fascination. In southern India, legends of the 7 pagodas at Mahabalipuram tell of temples lost to the sea. For centuries, the story was considered symbolic. Then, after a tsunami briefly pulled back the shoreline in 2002, stone structures became visible offshore. Subsequent dives confirmed the presence of walls, pillars, and carved elements beneath the waves. What had been myth gained a physical dimension. The sea had not destroyed the temples entirely, it had hidden them. These submerged sites matter because they force a reconsideration of where we expect to find evidence of early complexity. If people built monumental or semi-monumental structures in coastal zones, those achievements would be underrepresented in the archaeological record today. The absence of early cities on land does not necessarily mean they never existed. It may mean they existed where we have not yet fully looked. Rising seas were not the only challenge. As coastlines shifted, inland environments also changed. Freshwater sources moved, forests expanded or retreated, and familiar animal populations altered their ranges. Human groups were pushed into new territories, often already occupied by others. Competition increased. Old social networks fractured. Knowledge that had been stable within a region could lose relevance in a new landscape. Under such pressure, even sophisticated systems can unravel quickly. Memory, however, has a way of surviving collapse. Stories encode experience in symbolic form. A flood becomes a moral tale. A lost land becomes a paradise or a warning. Across cultures, flood myths share striking similarities: water rising beyond control, the destruction of most of humanity, and a small group of survivors who begin again. These narratives are not scientific records, but they are not arbitrary either. They reflect lived experiences filtered through generations. When seen against the backdrop of post-Ice Age sea level rise, these stories gain context. They are not evidence of a single global flood, but of many local catastrophes experienced repeatedly across different regions. Together, they form a mosaic of human response to environmental upheaval. They suggest that the end of the Ice Age was remembered not as a technical climate shift, but as an age-ending disaster. If civilizations or proto-civilizations had existed along ancient coasts, their loss would have been almost total. Stone can endure underwater, but wood, fiber, and most tools cannot. Writing, if it existed, would likely vanish. What would remain are foundations, alignments, and myths carried inland by survivors. Over generations, those myths would lose detail and gain meaning, transforming memory into legend. The world we inherit, therefore, is incomplete. It is a landscape edited by ice and water, where entire chapters of human experience may lie beyond easy reach. To understand the deep past, it is not enough to dig where the land remained. We must also reckon with what was taken by the sea, and with the possibility that history, as we tell it, begins only after a much older story was washed away. Long before archaeology had dates or climate models, human societies carried memory in story. These stories were not entertainment in the modern sense. They were containers for survival knowledge, moral order, and collective trauma. When environments collapsed, memory became the only bridge between what had been and what remained. This is why the same motifs appear again and again in cultures that never met. A sky that turns hostile, water that rises without limit, fire that sweeps the land, and a small remnant of humanity forced to begin again in a changed world. Flood narratives are the most widespread. In the ancient Near East, the story preserved in the Epic of Gilgamesh tells of a world-ending deluge sent to wipe humanity away. The survivor, warned in advance, builds a great vessel, preserves animals and seeds, and rides out the destruction until the waters recede. In the Hebrew tradition, the story of Noah follows a nearly identical structure, differing in theology, but not in its core sequence of events. The flood is total, survival is selective, and the post-flood world marks the beginning of a new age. In South Asia, the story of Manu describes a cosmic flood that destroys the world. Manu is warned by a small fish, later revealed as a divine being, and instructed to build a boat. When the waters rise, the fish guides the vessel to safety. Afterward, Manu becomes the ancestor of renewed humanity. The symbolism differs, but the memory is the same. A sudden inundation, survival through preparation, and the rebirth of civilization. Across the Pacific, indigenous traditions in the Americas echo similar themes. In Mesoamerican accounts, humanity passes through multiple worlds, each destroyed by catastrophe. One ends in flood, another in fire. The present world is not the first, but the latest. Among the Hopi of the American Southwest, stories speak of previous worlds destroyed when humans lost harmony with natural law. Survivors escape and are guided to safety, where they begin again under new conditions. These myths are often dismissed as metaphor, but metaphor does not arise from nothing. It condenses experience. When similar metaphors appear independently across continents, they suggest shared pressures rather than shared imagination. The end of the Ice Age provides such a pressure. Rising seas, destabilized climates, and sudden local disasters would have produced repeated experiences of loss and displacement. Over generations, these experiences hardened into narrative structures that outlived the events themselves. What makes these stories especially striking is their timing. Many flood myths situate their catastrophes at the boundary between ages, at moments when the world is said to reset. This aligns closely with the transition from the Pleistocene to the Holocene, the shift from the Ice Age world to the relatively stable climate in which agriculture and cities emerged. In this sense, myth and geology point to the same threshold, each using its own language. Scientific inquiry has tried to understand whether the end of the Ice Age included events dramatic enough to justify such memories. One line of investigation focuses on physical traces found in sediments dating to around 12,800 years ago, the beginning of the Younger Dryas. In multiple locations, researchers have identified dark sediment layers rich in charcoal and ash. These so-called black mats appear suddenly in the geological record and coincide with ecological disruption. Charcoal indicates fire, but not ordinary fire. The scale implied by these layers suggests widespread burning across continents. Forests and grasslands appear to have ignited over vast areas in a relatively short span of time. Such fires could be explained by extreme drought or lightning storms, but their near-synchronous appearance across distant regions has raised questions. Something may have acted as a trigger, pushing multiple systems past their limits at once. Another piece of evidence comes from microscopic diamonds found within these same layers. These nanodiamonds form only under intense pressure and heat, conditions typically associated with impacts or powerful explosions. Their presence doesn't prove a single catastrophic event, but it suggests that at least some regions experienced extraordinary energy release. Accompanying these diamonds are magnetic particles and unusual chemical signatures that further complicate simple explanations. Iridium anomalies add another layer to the puzzle. Iridium is rare on Earth's surface, but common in meteorites. Elevated levels of this element have been famously linked to the asteroid impact that ended the age of dinosaurs. Smaller iridium peaks have been reported in Younger Dryas boundary sediments at several sites. Critics argue these concentrations are inconsistent and could result from volcanic activity. Supporters countered that the pattern fits a fragmented impact scenario rather than a single crater-forming event. The debate remains unresolved, but the broader implication is clear. The end of the Ice Age was not uniform or gentle. It involved abrupt shifts, extreme events, and cascading failures across ecosystems. For human groups already under pressure from rising seas and disappearing resources, these shocks would have been devastating. Entire populations could have been displaced or lost, without leaving a clear archaeological trace. In such a context, the idea of cultural survivors takes on new meaning. Survival does not require technological advancement in the modern sense. It requires continuity of knowledge. A group that understood seasonal cycles, animal behavior, astronomy, or basic engineering would have an advantage in rebuilding after collapse. To later, less experienced groups, such survivors might appear extraordinary, even godlike, not because they were supernatural, but because they remembered what others had forgotten. This dynamic is reflected in many traditions that describe culture bringers arriving after a catastrophe. These figures teach agriculture, law, timekeeping, and construction. They are often associated with water, with survival, and with the restoration of order. Over generations, human teachers become divine ancestors. Memory transforms instruction into myth. Archaeology shows that after the Ice Age, human societies changed with remarkable speed. Within a few thousand years, agriculture appeared independently in multiple regions. Monumental architecture followed soon after. Writing, mathematics, and complex social hierarchies emerged in what appears, from a long-term perspective, as a sudden burst of innovation. This pattern does not require a lost civilization to explain it, but it does leave room for the possibility that knowledge accumulated earlier than we can currently document. The key point is not to replace one certainty with another, but to recognize the fragility of the record. Ice, water, and time are efficient erasers. They remove not only structures, but the context needed to interpret what remains. What survives does so unevenly, favoring inland, arid, or elevated regions. The deeper past, especially one tied to Ice Age coastlines and unstable climates, is therefore filtered through loss. Myth, science, and archaeology converge on the same conclusion. The transition out of the Ice Age was a profound rupture. Whether remembered as flood, fire, or falling stars, it marked the end of worlds and the beginning of something new. To understand what came before, we must listen carefully to the echoes that remain, even when they speak in the language of story rather than stone. Among all the discoveries that force a reconsideration of humanity's deep past, one site stands apart for its timing, scale, and implications. On a low ridge in southeastern Anatolia, massive stone pillars rise from the earth in circular arrangements that should not exist according to conventional expectations. This place, known today as Göbekli Tepe, dates to a period just after the end of the Ice Age, more than 11,000 years ago. It appears suddenly in the archaeological record, fully formed, without obvious precursors, and then is deliberately buried. Nothing about it fits comfortably within the old narrative of slow, incremental development. The builders of Göbekli Tepe lived before farming villages, before pottery, and before metal tools. According to traditional models, people of this era were small bands of hunter-gatherers focused almost entirely on survival. Yet the stones at Göbekli Tepe tell a different story. Some pillars rise more than 5 meters high and weigh several tons. They were quarried, shaped, transported, and erected with precision. Organizing such work would have required planning, coordination, and a shared purpose that extended beyond daily subsistence. Each stone pillar is carved with reliefs of animals and abstract forms. Foxes, snakes, boars, birds, and insects emerge from the limestone with deliberate clarity. These are not random decorations. They appear repeatedly, arranged in ways that suggest symbolic meaning. The pillars themselves are T-shaped, a form that many researchers interpret as stylized human figures. If so, then these circles may represent gatherings not just of stones, but of presences, standing in relation to one another across time. Radiocarbon dating places Göbekli Tepe's earliest construction around 9600 BC, within a few centuries of the Younger Dryas ending. This timing is critical. It situates the site at the threshold between worlds, when the climate stabilized and human societies began to reorganize. Rather than marking the birth of complexity, Göbekli Tepe may record an attempt to preserve something already known, something threatened by recent upheaval. One of the most discussed carvings is found on a pillar often called the vulture stone. Its surface is crowded with imagery: a large bird with outstretched wings, a scorpion, other animals, and a small circular disc. At first glance, these seem like mythic symbols or totems. Mainstream archaeology often interprets them as part of a ritual language connected to death, transformation, or the spirit world. In this view, vultures represent sky burials, a practice known from later cultures in the region, where bodies were exposed and bones later collected. Yet another interpretation has drawn intense attention. Using astronomical software to reconstruct the ancient sky, some researchers have suggested that the animals on the stone correspond to constellations. The scorpion aligns with the constellation Scorpio. Other figures match patterns associated with Virgo, Sagittarius, and Capricorn. In this reading, the disc carried by the bird represents a celestial object, possibly a comet fragment. When the arrangement is matched against sky models, the alignment corresponds closely to a date around 10,950 BC, near the onset of the Younger Dryas. If this interpretation is even partially correct, it suggests that the builders of Göbekli Tepe were not only keen observers of the sky, but were encoding specific events into stone. This would make the site not just a temple, but a memory device, preserving knowledge of a catastrophe that shaped their world. It would also imply a level of astronomical awareness far earlier than previously assumed. Critics rightly urge caution. Symbolic art can carry multiple meanings, and aligning animal figures with constellations risks imposing modern frameworks onto ancient minds. There is no written text to confirm intent, and coincidence cannot be ruled out. Still, the idea persists because it fits a broader pattern: the repeated association of monumental architecture with celestial observation in later civilizations. Regardless of how the carvings are interpreted, the scale of Göbekli Tepe remains undeniable. Hunter-gatherer societies are typically mobile, their social structures flexible and small. Coordinating the labor needed to build and maintain this site would have required stable leadership, shared rituals, and reliable food sources. Some researchers now believe that Göbekli Tepe itself may have driven the development of agriculture. Feeding large groups gathered for construction and ceremony could have encouraged the cultivation of plants, reversing the usual cause and effect relationship assumed in textbooks. In this light, Göbekli Tepe represents a pivot point. It suggests that complex social organization can precede farming, not follow it. This alone reshapes how we think about the origins of civilization. But there is another layer to consider. The site was intentionally buried after centuries of use. Thousands of tons of earth were piled over the stone circles, preserving them for millennia. This was not abandonment. It was closure. The deliberate burial raises difficult questions. Why invest so much effort in concealing something so monumental? One possibility is ritual, ending a sacred cycle by returning it to the earth. Another is protection. an attempt to preserve the site against forces perceived as dangerous, whether environmental or human. In either case, the act suggests foresight and intention, a concern for legacy rather than immediate survival. Göbekli Tepe does not stand alone. It exists within a broader region that would later give rise to some of the world's earliest farming communities. The Fertile Crescent, as it is often called, became a cradle of innovation soon after the Ice Age ended. The proximity of Göbekli Tepe to this transformation is unlikely to be coincidence. It may represent a bridge between Ice Age knowledge systems and the emerging Neolithic world. For those who entertain the idea of lost or diminished civilizations, Göbekli Tepe offers a powerful anchor. It does not prove that advanced societies existed before the Ice Age ended, but it demonstrates that our assumptions about early humans are incomplete. Skills, coordination, and symbolic thinking were present at levels previously thought impossible for that time. What Göbekli Tepe ultimately shows is not mystery for its own sake, but humility. The deep past is not empty. It is layered, fragile, and partially erased. When a site appears that contradicts expectation, the correct response is not dismissal, but careful reconsideration. At the edge of the Ice Age, humans were not simply waiting for civilization to begin. They were already building meaning into stone, responding to a world that had nearly ended, and shaping the foundations of what would come next. If Göbekli Tepe represents a memory carved into stone, then it also raises a broader question. How much knowledge can survive catastrophe without writing? Long before ink, paper, or tablets, human societies relied on other systems to preserve information across generations. Story, ritual, symbol, and alignment with the natural world functioned as living archives. When environments were stable, these systems accumulated gradually. When environments collapsed, they became lifelines. One of the most enduring methods of preserving long-term knowledge was observation of the sky. Unlike landscapes which could flood or burn, the heavens followed predictable cycles. Stars rose and set, the sun marked seasons, and the moon governed tides and time. For Ice Age peoples facing uncertainty on the ground, the sky offered consistency. Over generations, patterns were noticed, remembered, and encoded into practice. This is why, in later civilizations, monumental architecture so often aligns with celestial events. These alignments are not decoration. They are functional markers of time, allowing communities to anticipate seasonal change, migration cycles, and agricultural windows. Even without farming, such knowledge would have been invaluable. Knowing when herds moved, when rivers froze or thawed, or when storms were likely to arrive could mean the difference between survival and collapse. Evidence of this sky-ground connection appears repeatedly after the Ice Age. Stone circles, passage tombs, pyramids, and ceremonial centers across the world share a common feature. They are oriented toward solstices, equinoxes, or prominent stars. This pattern does not require a single source, but it does suggest a shared human response to uncertainty. When the world becomes unstable, people look upward for order. The phenomenon of precession adds depth to this pattern. Earth's axis slowly wobbles over a cycle of about 26,000 years, causing the position of stars to shift gradually over long periods. This movement is subtle, invisible within a single lifetime, but obvious when tracked over centuries. Recognizing precession requires not only observation, but the transmission of knowledge across many generations. If ancient peoples were aware of it, even indirectly, they possessed a time horizon far longer than often assumed. Some researchers argue that traces of this awareness appear in myth and monument. Stories of ages ending and beginning, of worlds ruled by different gods, may reflect slow celestial change translated into narrative. Alignments that no longer match their original targets hint that builders may have encoded sky positions relevant to their own time, leaving later generations to inherit structures whose meaning slowly drifted. This possibility becomes especially compelling when paired with the idea of survival after catastrophe. If a group preserved astronomical knowledge through the end of the Ice Age, that knowledge would have been a powerful tool in rebuilding. Teaching others to read the sky would grant authority, not because of supernatural power, but because prediction appears miraculous to those without context. Over time, teachers become ancestors, and ancestors become gods. Many ancient traditions describe culture bringers who arrive after a disaster. They teach people how to measure time, build, plant, and organize society. In Mesoamerica, figures associated with the planet Venus play this role. In Egypt, a god linked to writing and measurement embodies cosmic order. In Mesopotamia, wisdom is said to emerge from beings connected with water and survival. These themes are remarkably consistent, even when the names and symbols differ. Archaeology shows that after the Ice Age, complex knowledge appears rapidly in several regions. Writing systems emerge that are already capable of recording law, trade, and astronomy. Mathematical frameworks appear that handle geometry and large numbers. Architectural plans reflect precise orientation and proportion. These developments can be explained through favorable environments and human creativity, but their speed remains striking. One of the most intriguing cases is early Mesopotamia. The sudden appearance of organized city-states, administrative systems, and cuneiform writing suggests a compressed learning curve. Sumerian texts themselves speak of earlier epochs, times before the flood when kingship descended from the heavens. These are not historical records in the modern sense, but they preserve a belief that civilization was inherited, not invented. This belief does not require literal descent from the sky. It can be read as a metaphor for knowledge arriving from outside the immediate community, from those who survived something others did not. In a world reshaped by water and climate, survivors from different regions would have carried different skills. When they met emerging farming communities, their combined knowledge could accelerate development dramatically. The role of ritual in this process cannot be ignored. Ritual stabilizes memory. It encodes practice into repeated action, making knowledge resilient to loss. Göbekli Tepe's animal carvings, repeated across pillars, may represent a symbolic system used to organize and transmit information. Even without writing, such systems can be remarkably precise, especially when reinforced through communal participation. Importantly, this does not imply a single lost global civilization. Human history does not require a hidden empire to explain complexity. It requires only the recognition that knowledge can accumulate, be disrupted, and reappear in altered form. The end of the Ice Age provided the disruption. The early Holocene provided the conditions for reassembly. What makes this perspective unsettling is that it undermines the idea of a clean beginning. Civilization, as we define it, may be less a starting point than a recovery. The familiar story of progress from simplicity to complexity becomes less linear, more cyclical. Advances are not guaranteed. They can be lost, fragmented, and rediscovered under pressure. Seen this way, ancient monuments are not primitive experiments, but responses to vulnerability. They anchor memory in stone because memory in people is fragile. They align with the sky because the sky endures when land does not. And they gather communities because survival after collapse is not an individual act, but a collective one. The Ice Age did not end with a gentle thaw into civilization. It ended with upheaval that forced humans to rethink their relationship with time, space, and knowledge. What followed was not creation from nothing, but reconstruction from fragments. And within those fragments, encoded in stone, story, and star, lies the possibility that humanity remembers more than it consciously knows. When the conversation turns from stone circles and submerged coastlines to written philosophy, one name inevitably surfaces. Plato did not claim to invent the story of Atlantis. He presented it as an inheritance, a memory passed down through Egyptian priests and carried to Greece by Solon generations before his own time. In Plato's telling, Atlantis was not a vague mythic land, but a powerful civilization that existed long before classical Greece, destroyed suddenly by earthquakes and floods in a single day and night. What gives the story its enduring power is not its drama, but its specificity. Plato placed Atlantis beyond the Pillars of Hercules, in the Atlantic world. He described its geography, its concentric rings of land and water, its harbors, its laws, and its downfall. Most importantly, he dated its destruction to roughly 9,600 BC, a time that aligns closely with the end of the Ice Age and the final surge of global sea level rise. This coincidence alone has ensured that Atlantis has never fully faded into fiction. Modern readers often assume Plato used Atlantis purely as allegory, a moral lesson about hubris and decline. Yet Plato distinguished Atlantis from his known fictional devices. He framed it as history, not metaphor, and insisted it came from an older tradition. While this does not guarantee its literal truth, it does raise a critical point. Ancient writers did not draw hard lines between history, memory, and meaning. For them, a story could be true without being exact, preserving the essence of events even as details shifted. Seen through the lens of post-Ice Age change, Atlantis becomes less mysterious and more plausible in concept, if not in detail. Around the time Plato specifies, sea levels were rising rapidly as the last great ice sheets melted. Coastal plains vanished, islands fragmented, and low-lying regions were claimed by the ocean. To people living through this transition, land was not permanent. It could be lost within generations. A powerful coastal culture could disappear without leaving much behind. Rather than representing a single empire, Atlantis may be a composite memory. It could symbolize many drowned worlds rather than one specific city. Plato's concentric rings might echo harbors, islands, or engineered waterways remembered imperfectly across centuries. His description of sudden destruction fits what would have been experienced during extreme flooding, tsunamis, or rapid shoreline collapse. Attempts to locate Atlantis physically have followed this logic. Some have looked westward to the Azores, volcanic islands rising sharply from the Atlantic floor. The idea is tempting because the islands appear like mountain peaks emerging from a submerged landmass. Yet geological evidence shows the Azores have been islands for millions of years, making them unlikely remnants of a lost Ice Age continent. Others have placed Atlantis in more unexpected locations. Antarctica has been proposed based on ancient maps that appear to show ice-free coastlines. However, geological data confirms that Antarctica has been covered in ice far longer than human history allows. These theories persist not because they are strong, but because the underlying intuition remains unresolved. The sense that something real lies behind the story. One of the more intriguing proposals centers on the Richat structure in Mauritania, sometimes called the Eye of the Sahara. This massive circular formation, visible from space, bears a striking resemblance to Plato's description of concentric rings. During the Ice Age, the Sahara was far wetter than today, with rivers, lakes, and grasslands supporting life. In such an environment, the Richat structure could have been a prominent landmark. Yet geology explains it as a natural erosion feature, and no clear archaeological evidence ties it to an advanced prehistoric culture. What unites all these theories is not proof, but context. Each attempt places Atlantis within environments that changed dramatically at the end of the Ice Age. The focus shifts away from searching for a sunken metropolis and toward understanding the scale of loss during this period. Entire regions were transformed beyond recognition. For the people who lived there, this would have been the end of the world as they knew it. Plato's account also emphasizes moral decay preceding destruction. Atlantis falls not just because of natural forces, but because its people lose balance and restraint. This theme mirrors many flood myths, where catastrophe is framed as consequence rather than accident. While modern science rejects moral causation, this narrative structure reflects how human societies process trauma. Disaster becomes meaningful when it is woven into ethics and identity. Importantly, Plato contrasts Atlantis with ancient Athens, portraying Athens as a simpler, more virtuous society that survives while Atlantis does not. This inversion complicates the idea that Atlantis represents ultimate advancement. It suggests instead a warning. Complexity alone does not ensure resilience. A society deeply tied to vulnerable landscapes, especially coastal ones, may be more exposed to environmental change. This perspective aligns with what we know of the Ice Age transition. Coastal abundance encourages growth, trade, and specialization, but it also creates dependency on stable sea levels. When those levels rise, the advantages become liabilities. Inland societies may survive longer simply because their environments change more slowly. Atlantis, then, may represent the memory of societies that thrived in Ice Age conditions but failed to adapt quickly enough when those conditions vanished. Their knowledge did not disappear entirely. It fragmented. Pieces survived in myths, in rituals, in architectural ideas carried inland by refugees. Over time, the origin of these ideas blurred, and their sources were elevated into legend. This interpretation does not require believing in lost supertechnology or global empires. It requires accepting that human societies can reach significant levels of organization and then collapse almost completely under environmental stress. History offers many smaller examples of this pattern. The end of the Ice Age was simply the largest version humanity has ever faced. What Plato preserved, intentionally or not, may be the emotional truth of that collapse. A world that believed itself powerful and permanent was undone by forces it could not control. The memory of that loss endured long enough to be written down, filtered through philosophy, and debated thousands of years later. Atlantis remains unresolved, not because evidence is hidden, but because the past it points to was unstable by nature. It existed on land that no longer exists, during a time when the Earth itself was in transition. In that sense, Atlantis is not a destination to be found, but a reminder of how much of human history lies beyond the shoreline, beneath the water, and outside the neat boundaries of our timelines. If stories like Atlantis preserve emotional truth, then science seeks physical rhythm. To understand whether the end of the Ice Age was an anomaly or part of a repeating pattern, researchers turned their attention away from myth and toward the sky itself. The most influential framework to emerge from this effort explains Earth's long-term climate changes not as chaos, but as consequence. It rests on the geometry of the planet's orbit and the slow, predictable movements that govern how sunlight reaches the surface. In the early 20th century, a mathematician and astronomer working largely in isolation calculated that small variations in Earth's motion could have enormous climatic effects. Changes in the shape of Earth's orbit, the tilt of its axis, and the slow wobble of that axis altered the distribution of solar energy across the planet. These variations unfold over tens of thousands of years, far beyond human perception, yet they determine whether ice sheets grow or melt. The first of these movements involves eccentricity, a measure of how circular or elliptical Earth's orbit is. Over a cycle of roughly 100,000 years, the orbit shifts subtly, changing how evenly sunlight is received throughout the year. When the orbit is more elliptical, seasonal contrasts become slightly stronger. This alone does not cause ice ages, but it sets the stage for other forces to act more powerfully. The second movement is obliquity, the tilt of Earth's axis. Today, the axis is tilted a little over 23 degrees, giving rise to seasons. Over a cycle of about 41,000 years, this tilt varies. A greater tilt produces hotter summers and colder winters, especially at high latitudes. Hotter summers are critical because they determine whether winter snow fully melts. If snow persists year after year, it compresses into ice, allowing glaciers to expand. The third movement is precession, the slow wobble of Earth's axis, similar to the motion of a spinning top. This cycle lasts about 26,000 years and changes the timing of seasons relative to Earth's position in its orbit. At certain points, the northern hemisphere experiences summer when Earth is farthest from the sun, resulting in cooler summers. At other times, summer occurs when Earth is closest, intensifying warmth. This timing strongly influences whether ice sheets retreat or advance. Together, these three cycles regulate Earth's glacial rhythm. They do not operate in isolation, but in combination, amplifying or weakening one another over long spans of time. The crucial factor is summer sunlight in the northern hemisphere. When summer energy is low, ice survives. When it is high, ice melts. This principle explains why ice ages begin and end when they do, without invoking randomness or catastrophe. For decades, these ideas were theoretical. Then physical evidence emerged. Deep-sea sediment cores revealed repeating patterns in oxygen isotopes, chemical signatures that reflect global ice volume. Ice cores drilled from Greenland and Antarctica preserved layered records of snowfall, temperature, and atmospheric composition stretching back hundreds of thousands of years. These records matched the predicted timing of orbital cycles with remarkable accuracy. The conclusion was clear. Ice ages are not accidents. They are part of a long-term, celestial rhythm. Warm periods like the one we live in, known as interglacials, are temporary intervals between much longer cold phases. The Holocene, which began around 11,700 years ago, is one such interval. By natural cycles alone, it should last for thousands more years before another descent into ice begins. This understanding reshapes how we view the end of the Ice Age. It suggests that the planet was already moving toward warming due to orbital conditions. The retreat of glaciers was expected. What stands out is not the warming itself, but the interruptions within it, such as the Younger Dryas. These abrupt reversals do not contradict orbital theory, but they do highlight the sensitivity of the climate system to additional triggers. Orbital forcing sets the pace, but feedbacks control the intensity. Greenhouse gases, especially carbon dioxide, amplify changes by trapping heat. As ice melts, darker land and water absorb more sunlight, accelerating warming. Conversely, expanding ice reflects sunlight, reinforcing cooling. Ocean circulation redistributes heat, and disruptions can produce rapid regional shifts even when global trends remain steady. Within this framework, sudden events are possible without breaking the overall rhythm. A large volcanic eruption can inject aerosols into the atmosphere, temporarily cooling the planet. Massive freshwater release from melting ice can weaken ocean currents, as suspected during the Younger Dryas. Even impacts from space, while rare, could impose short-term shocks on a system already near a threshold. This perspective carries an important implication for human history. If climate operates in cycles, then periods of stability like the early Holocene are windows of opportunity rather than permanent states. Civilization, agriculture, and large-scale settlement emerged during a rare calm between extremes. They are not the default condition of human existence, but a response to an unusually forgiving environment. For Ice Age peoples, survival required mobility, flexibility, and local knowledge. For Holocene societies, stability encouraged permanence, specialization, and growth. When the environment stopped oscillating violently, humans could afford to invest in fields, buildings, and long-term planning. This shift happened quickly because the underlying potential had always been there, constrained previously by climate rather than capability. Seen through this lens, the sudden flowering of civilization does not require lost golden ages. It requires release from pressure. However, this does not negate the trauma of transition. The move from an Ice Age world to a warmer one involved enormous loss, particularly along coasts and in regions dependent on cold-adapted ecosystems. The memory of that loss would persist even as new societies took shape. Orbital theory also forces a sobering realization. The climate system has always changed, and it will change again. The stability that allowed civilization to emerge is temporary on geological timescales. Human influence now adds a new variable, altering greenhouse gas concentrations far faster than natural processes typically allow. This does not stop orbital cycles, but it can distort their effects, delaying or intensifying future transitions. The people who lived through the end of the Ice Age did not know orbital mechanics, but they knew instability. They responded by encoding memory in story, monument, and ritual. Today, we have equations and data, but we face a similar challenge. Understanding that our environment is not fixed, and that resilience depends on recognizing patterns rather than assuming permanence. The rhythm of ice and warmth continues, indifferent to human timelines. The question is not whether change will come, but how societies prepare for it. In this sense, the Ice Age is not a closed chapter. It is a reminder written into the structure of the planet itself, warning that what feels permanent is often only a pause between transformations. While orbital cycles explain the broad rhythm of ice and warmth, they do not capture the lived reality of collapse. Climate models describe averages and trends, but human experience unfolds locally, abruptly, and unevenly. For communities at the margins of survival, a shift of a few degrees or a change in seasonal timing could unravel entire ways of life. The end of the Ice Age was therefore not a single event, but a cascade of regional crises, each one reshaping human societies in distinct yet interconnected ways. As temperatures fluctuated and ecosystems reorganized, familiar food sources disappeared. Plants that thrived in cold, dry conditions were replaced by species better suited to warmth and moisture. Animals adapted to open steppe retreated northward or vanished altogether. For hunter-gatherers whose survival depended on intimate knowledge of these systems, such changes were disorienting. Roots learned over generations lost their usefulness. Seasonal expectations failed. Knowledge that once guaranteed survival suddenly misled. Archaeological layers from this period often show signs of disruption. Settlements are abandoned. Tool traditions change rapidly. In some regions, population density appears to decline sharply. These are not signs of gradual adaptation, but of stress. When environments change faster than culture can respond, collapse becomes a real possibility. Groups fragment, migrate, or disappear into the archaeological silence. The extinction of megafauna intensified this pressure. Large animals were more than food. They structured human economies. Their predictable movements shaped migration patterns. Their bones provided tools, shelter frames, and fuel. When these animals declined, human groups were forced to diversify rapidly or face starvation. Smaller game and plant resources required different technologies and social strategies, accelerating cultural change under duress. In North America, the disappearance of mammoths and other large mammals coincides closely with the end of the Ice Age. Some researchers emphasize climate stress, others human hunting, and still others a combination of both. Regardless of cause, the result was the same: a sudden break with the past. Cultures organized around big game hunting had to reinvent themselves within a few generations. Similar patterns appear elsewhere. In Eurasia, cold-adapted species retreated, forests expanded, and open landscapes closed in. Dense woodland supports different resources, but also limits visibility and movement. Hunting strategies that worked on open plains became ineffective. New tools, traps, and social coordination were required. The transition favored innovation, but innovation under pressure often leaves casualties. These environmental stresses also reshaped social organization. Mobility decreased as some groups began to exploit localized resources more intensively. Seasonal camps became more permanent. Storage became valuable. Control of fertile land or reliable water sources increased in importance, setting the stage for inequality and territoriality. What later societies would recognize as property and hierarchy began as survival strategies. This context helps explain why agriculture appeared independently in several regions after the Ice Age. farming was not an obvious improvement. It required more labor, carried risks of crop failure, and tied people to specific locations. Yet in a world where traditional resources were unreliable, cultivation offered predictability. It transformed landscapes into managed systems, trading freedom for control. The shift to agriculture was not instantaneous or universal. Many groups resisted it for centuries, preferring flexible subsistence strategies. But once established, farming supported larger populations and denser settlements. These concentrations created new vulnerabilities, including disease and social tension, but they also enabled specialization. Craft, administration, and ritual expanded as not everyone needed to gather food. This is where the memory of collapse becomes crucial. Early agricultural societies did not emerge from ignorance. They emerged from experience. Their ancestors had lived through instability and loss. The drive to control food, time, and environment reflects a desire to avoid repeating that trauma. In this sense, civilization can be seen as a defensive adaptation to climate uncertainty. Evidence of this mindset appears in early monuments and myths. Structures align with solar and seasonal markers, ensuring that critical agricultural moments are not missed. Stories warn of floods, droughts, and divine displeasure, embedding caution into culture. Rituals reenact creation and destruction, reminding communities of fragility even in times of abundance. Importantly, these responses vary by region. In the Near East, early farming focused on grains that could be stored, providing insurance against bad years. In East Asia, rice cultivation developed in floodplains, requiring communal coordination to manage water. In the Americas, maize was gradually transformed from a wild grass into a staple capable of supporting large populations. Each system reflects local conditions and histories of stress. What unites them is timing. All emerge after the Ice Age, within a narrow window of global warming and relative stability. This coincidence is not accidental. It suggests that the Holocene provided a climatic opportunity, but one that was seized by societies shaped by prior collapse. The memory of instability drove innovation as much as the promise of abundance. This perspective challenges the idea of linear progress. Rather than moving steadily upward, human societies oscillate between expansion and contraction. Periods of stability allow complexity to flourish. Periods of disruption strip it away. The end of the Ice Age was a reset, not to zero, but to a different configuration of possibilities. The archaeological record, incomplete as it is, captures this unevenness. It shows bursts of creativity following gaps of silence. It reveals technologies appearing fully formed, without clear developmental stages. These patterns are often explained by preservation bias, but they also reflect real social dynamics. When collapse occurs, continuity breaks. What follows may look sudden simply because intermediate steps were lost. Understanding this cycle reframes debates about lost civilizations. The question is not whether a global advanced culture existed, but how much knowledge and organization were repeatedly built and lost in response to environmental change. Complexity does not require permanence. It can arise, vanish, and reappear under different forms. For the people living at the dawn of the Holocene, the world felt both promising and dangerous. Ice retreated, opening new lands, but memories of flood and cold lingered. The future was uncertain, and survival demanded vigilance. The choices made in that moment shaped the trajectory of human history, not as a triumph over nature, but as a negotiation with forces far larger than any society. In this light, the end of the Ice Age was not simply the end of an era. It was a test. Humanity passed it, not by mastering the planet, but by adapting its cultures, stories, and structures to a world that had proven capable of sudden and unforgiving change. Among the most haunting remnants of the Ice Age are the bodies that never fully returned to the Earth. In the frozen ground of Siberia, Alaska, and parts of northern Canada, explorers have uncovered the remains of mammoths preserved with startling clarity. Fur still clings to skin. Flesh remains intact. In a few cases, undigested plants rest in the mouth or stomach, as if death arrived in the middle of a meal. These discoveries have fueled speculation for more than a century, not because preservation itself is mysterious, but because it suggests speed. Something happened fast enough to trap life between one moment and the next. To understand why these finds matter, it helps to consider how rare such preservation is. Large animals usually decay quickly. Scavengers, bacteria, and exposure reduce bodies to bone in a matter of weeks or months. For soft tissue to survive, burial and freezing must occur almost immediately. In modern permafrost environments, this can happen if an animal falls into mud, waterlogged soil, or a collapsing riverbank and is rapidly sealed by cold. This explanation accounts for many frozen remains. Yet the clustering of such finds near the end of the Ice Age continues to raise questions. Some early interpretations proposed an instant freeze, a sudden and extreme temperature drop that flash froze animals across vast regions. This idea captured the imagination because it aligned with a sense of catastrophe. However, modern climate science does not support a single global temperature collapse of that magnitude occurring in minutes or hours. Cooling, even during abrupt events like the Younger Dryas, unfolded over years or decades. Still, the debate highlights something important. The late Ice Age was capable of producing lethal conditions quickly enough to overwhelm large, well-adapted animals. The extinction of megafauna remains one of the most debated topics in prehistory. Mammoths, mastodons, giant ground sloths, saber-toothed cats, woolly rhinoceroses, and many others disappeared within a relatively short window between roughly 15,000 and 10,000 years ago. These species had survived multiple glacial cycles before. They endured colder temperatures, shifting vegetation, and long periods of scarcity. Their sudden disappearance at the end of the last Ice Age suggests a convergence of pressures rather than a single cause. Climate change altered habitats dramatically. As temperatures warmed, open grasslands gave way to forests in many regions. Animals adapted to grazing struggled as their food sources declined. At the same time, melting ice changed river systems and wetlands, affecting migration routes. Stress accumulated gradually, weakening populations. Into this fragile balance stepped humans, increasingly skilled hunters with efficient tools and coordinated strategies. Human hunting alone may not explain the scale of extinction, but it likely played a critical role. Large animals reproduce slowly. Even modest increases in mortality can push stressed populations past the point of recovery. When combined with rapid environmental change, the result can be collapse. The disappearance of megafauna was therefore not an isolated tragedy. It was part of a broader ecological reset that reshaped entire continents. For human societies, this loss was profound. Megafauna were keystone resources. They provided meat, fat, hides, bone, and ivory. Entire cultural systems revolved around them. Art carved into cave walls and portable objects shows deep familiarity with these animals, not as abstract symbols, but as central figures in daily life. When they vanished, those cultural systems lost their foundation. The archaeological record reflects this disruption. In many regions, tool traditions shift abruptly after megafauna decline. Large spear points give way to smaller, more versatile implements suited for hunting different prey. Settlement patterns change. Mobility decreases in some areas as people turn to localized resources. In others, migration intensifies as groups search for new opportunities. These transitions are not smooth. They show signs of experimentation under pressure. What is often overlooked is the psychological impact of such loss. For generations, human identity had been intertwined with these animals. Their disappearance would have been experienced not just as economic hardship, but as the end of a familiar world. Stories, rituals, and beliefs built around them would lose relevance. This kind of cultural rupture leaves scars that persist long after physical conditions stabilize. In this context, myths of destruction and renewal take on deeper meaning. The death of great animals, the flooding of lands, and the failure of old ways would naturally be woven into narratives explaining why the world changed. These stories do not need to be literal to be true. They preserve the emotional reality of collapse, giving shape to experiences that defy simple explanation. The frozen mammoths, then, are not evidence of a single dramatic event that killed everything at once. They are markers of a threshold, moments where life crossed into death under conditions that prevented the usual erasure. They remind us that the Ice Age did not end politely. It ended through a series of shocks that pushed ecosystems beyond resilience. Some researchers have suggested that these shocks may have included regional disasters such as floods, landslides, or even airbursts from fragments of cosmic debris. While definitive proof remains elusive, such events are not unprecedented. In 1908, an atmospheric explosion over Tunguska flattened thousands of square kilometers of forest in Siberia without leaving a crater. A similar event over Ice Age landscapes, already stressed by climate change, could have had devastating local effects. Whether or not such impacts occurred, the broader picture remains one of vulnerability. Large systems, whether ecological or cultural, can appear stable until they are not. Once thresholds are crossed, change accelerates. The Ice Age world, with its megafauna and wide plains, was one such system. Its collapse forced humanity into a new relationship with the environment. Survival after such collapse depends on flexibility and memory. Groups that could adapt their diets, tools, and social structures endured. Those that could not vanished, leaving little trace. Knowledge became fragmented, carried by survivors into new contexts. Over time, fragments recombined, giving rise to innovations that seem sudden when viewed without their lost background. This is why the post-Ice Age world appears to leap forward. Agriculture, architecture, and complex societies emerge rapidly because they are built on foundations laid earlier under different conditions. The disappearance of megafauna and the end of the Ice Age cleared ecological and cultural space, but it also erased continuity. What followed was not the first attempt at complexity, but the most recent one to survive. The frozen remains locked in permafrost are therefore not curiosities. They are reminders of how narrow the margin between stability and collapse can be. They show that entire ways of life can end within a few generations, leaving behind only scattered traces and stories. In confronting them, we are not just looking at extinct animals. We are glimpsing a moment when the world changed faster than memory could keep up, forcing humanity to begin again on unfamiliar ground. When the first cities rose from the floodplains of Mesopotamia, they did so with a speed that still unsettles historians. Within a few centuries, humans were no longer living only in scattered villages, but in organized urban centers with temples, administrative systems, trade networks, and written language. This sudden coherence stands in sharp contrast to the tens of thousands of years that came before, when human societies changed slowly and locally. The question is not whether humans were capable of such complexity, but why it appeared so abruptly. The Sumerians themselves did not claim to have invented civilization from nothing. Their earliest texts describe a world shaped by forces older than humanity as they knew it. Kingship, law, agriculture, and sacred knowledge were said to descend from powerful beings who existed before the current age. These narratives are often interpreted as mythology, but they also reveal how the Sumerians understood their own origins, as inheritors rather than originators. Cuneiform writing appears in the archaeological record already capable of accounting, record-keeping, and symbolic abstraction. It does not begin as crude pictographs slowly evolving toward complexity. Instead, it emerges functional, adaptable, and sophisticated. The same is true of Sumerian mathematics, which used place value and geometric principles advanced enough to support large-scale construction and land measurement. Such systems typically require long periods of experimentation, yet their formative stages are largely invisible. One explanation is preservation bias. Early experiments may have existed but were written on perishable materials that did not survive. Another explanation points to concentrated innovation driven by environmental opportunity. The fertile soils of the Tigris and Euphrates rivers supported surplus food production, freeing individuals to specialize. Once specialization began, complexity accelerated. This model is plausible, but it does not fully address why similar leaps occurred independently in other regions within a relatively short span of time. Across Egypt, the Indus Valley, and later in Mesoamerica, early civilizations display parallel features: monumental architecture, calendrical systems, centralized authority, and symbolic writing. These developments are separated by geography, but united by timing. All arise after the Ice Age, during the Holocene's early stability. This pattern suggests a global response to shared conditions rather than isolated miracles of genius. Some researchers have proposed that survivors of Ice Age collapse carried fragments of advanced knowledge into the post-glacial world. This does not imply advanced technology in the modern sense, but rather refined understanding of astronomy, engineering, and social organization developed under earlier conditions. When these survivors encountered emerging farming communities, their knowledge could catalyze rapid transformation. To small, recently settled groups, such knowledge would appear extraordinary. The ability to predict eclipses, organize irrigation, or design monumental structures would confer immense authority. Over generations, These teachers could be remembered not as human, but as gods or demigods. Myth would elevate memory, preserving influence while obscuring origin. This process can be seen in the role attributed to civilizing figures across cultures. In Mesopotamia, beings associated with wisdom and water guide humanity through floods and chaos. In Egypt, knowledge is brought by figures tied to order, measurement, and writing. In the Americas, deities arrive after destruction to restore balance and teach agriculture and law. The details differ, but the structure is consistent: catastrophe, survival, instruction, renewal. Importantly, these traditions do not describe humanity learning gradually through trial and error. They describe sudden transmission. Knowledge appears whole, delivered rather than discovered. From a modern perspective, this can be read as mythic shorthand for cultural inheritance. Complex systems feel sudden to those who receive them without experiencing their development. Archaeology increasingly supports the idea that early urban societies built upon deeper roots than once assumed. Sites like Göbekli Tepe show that coordination, symbolism, and large-scale construction existed before farming. This undermines the assumption that agriculture was the sole trigger for civilization. Instead, it suggests that social complexity can arise under different conditions and persist through disruption. The idea of lost knowledge does not require a vanished global empire. It requires only that humans experimented with complexity earlier than we can fully document, and that much of that experimentation was erased by environmental change. Rising seas, shifting climates, and population collapse would selectively destroy evidence, leaving behind only fragments capable of survival. Those fragments would not look like modern blueprints. They would appear as myths, alignments, ritual practices, and symbolic systems. Over time, these elements would be absorbed into new cultures, reshaped to fit new environments. Their origins would fade, but their influence would remain. This helps explain why early civilizations often appear simultaneously advanced and symbolic. Their architecture is not purely functional. It encodes cosmology. Their laws are not merely pragmatic. They reflect moral order tied to cosmic balance. Such integration suggests that practical knowledge and worldview developed together, shaped by experiences of instability and loss. The end of the Ice Age did not wipe humanity clean. It filtered humanity. Groups survived with different skills, memories, and traditions. When conditions stabilized, these elements recombined in novel ways. The result was not a simple continuation of the past, but a reconfiguration of it. Seen this way, the rise of civilization is not a mystery, but a recovery. It is what happens when pressure lifts, but memory remains. The sudden appearance of writing, mathematics, and monumental architecture reflects the release of long-suppressed potential, guided by fragments of inherited knowledge that had survived collapse. What we call the beginning of history may therefore be misleading. It is not the first chapter, but the first chapter that endured long enough to write itself down. Everything before it existed in forms that were vulnerable to erasure. The Ice Age did not prevent complexity. It hid it, scattered it, and forced it to re-emerge under new rules. The Sumerians looked backward when they explained their world. They believed they stood at the edge of something much older. Whether that belief was literal or symbolic, it shaped their culture and their sense of place in time. In doing so, it preserved a truth modern archaeology is only beginning to confront. That human history may not be a straight ascent, but a series of recoveries from worlds that ended before they could be remembered. When ancient cultures spoke of gods arriving after catastrophe, they were not necessarily describing beings from another realm. They were describing asymmetry. In a shattered world, those who remembered more appeared powerful. Those who could measure time, predict seasons, or organize labor seemed to stand apart from ordinary survival. Over generations, this difference hardened into mythology, transforming human knowledge into divine origin. Across civilizations, the figures credited with restoring order share striking traits. They emerge after floods or destruction. They are associated with water, sky, or rebirth. They teach agriculture, law, architecture, and astronomy. Most importantly, they do not invent chaos. They end it. Their role is not conquest, but stabilization. This pattern suggests a cultural memory of reconstruction rather than creation. In Mesopotamia, wisdom flows from beings linked to deep waters, a symbolic source of both destruction and renewal. In Egypt, order is personified as balance between earth and sky, measured through geometry and timekeeping. In Mesoamerica, civilizing figures arrive from the east or from the sea, bringing calendars and moral codes. These stories differ in form, but converge in function. They explain how structure returned after collapse. The language of divinity reflects distance. As centuries pass, the human origin of knowledge becomes harder to trace. Teachers become ancestors. Ancestors become gods. What began as practical instruction evolves into sacred narrative. This is not deception, but compression. Memory simplifies what it cannot preserve in detail. Archaeology offers indirect support for this process. Early civilizations often show advanced planning without clear developmental stages. Irrigation systems appear capable from the outset. Urban layouts follow cosmological principles from their earliest phases. These features imply inherited frameworks rather than spontaneous invention. They suggest that some organizing principles were already understood when cities formed. The role of water management illustrates this clearly. Controlling floods and irrigation requires long-term observation of seasonal cycles, river behavior, and soil response. Mistakes are costly. A society that succeeds in this does not learn entirely through failure. It applies accumulated knowledge. In regions like Mesopotamia and the Nile Valley, early water control systems appear with a level of sophistication that implies prior experience. Calendrical systems reinforce the same conclusion. Tracking solar years, lunar months, and seasonal markers requires generational continuity. Calendars do not emerge overnight. They are refined through observation and correction. Yet many early calendars appear already well aligned with astronomical cycles. This suggests that observation began long before writing fixed the results. Architecture further supports this view. Monumental structures often encode mathematical ratios, cardinal orientation, and celestial alignment. These are not intuitive outcomes of trial and error. They require abstract thinking and transmission of concepts. When such features appear suddenly in the archaeological record, it implies that the conceptual groundwork existed earlier, even if its physical traces were lost. This does not mean ancient societies possessed hidden modern science. It means they developed sophisticated observational knowledge appropriate to their needs and environments. The Ice Age world demanded close attention to seasonal variation, animal behavior, and celestial patterns. Such attention, sustained over millennia, would naturally produce systems of knowledge that later civilizations could inherit. The transition from oral to written tradition marked a turning point. Writing freezes knowledge in form, but it also narrows it. What is written down is what matters most at the time. Earlier layers of meaning, once carried through ritual and story, can be lost or simplified. When Sumerian scribes recorded myths of gods and floods, they captured only the surface of much older memories. This helps explain why ancient texts often speak of previous ages that ended in destruction. These are not historical chronicles, but acknowledgments of discontinuity. They admit that the present world is not the first, and that something fundamental was lost. Such admissions are rare in modern narratives of progress, which prefer continuity and ascent. The idea that knowledge survives catastrophe in fragmented form also explains why similar myths appear independently. Groups experiencing parallel conditions develop parallel responses. Collapse produces survivors. Survivors carry memory. Memory becomes structure. Structure becomes culture. The specific symbols differ, but the underlying process repeats. Importantly, this perspective reframes the debate about lost civilizations. It removes the need for hidden superpowers or vanished empires. It replaces them with something more plausible and more unsettling: repeated cycles of partial forgetting. Humanity does not start over from nothing, but it never carries everything forward either. What survives is shaped by circumstance. Skills tied to vanished environments become irrelevant. Others, adaptable and abstract, endure. Astronomy survives because the sky remains. Geometry survives because space still needs measuring. Social organization survives because cooperation remains essential. These are the threads that pass through collapse. The early gods of civilization, then, may represent nodes of continuity. They embody the transfer of surviving knowledge into new social contexts. Their stories preserve the idea that wisdom came from before, from a time beyond living memory. Whether literal or symbolic, this belief shaped how early societies understood themselves. This understanding carries a quiet warning. If knowledge can be lost once, it can be lost again. Writing and technology increase resilience, but they do not guarantee permanence. Environmental change, social breakdown, or resource collapse can still fracture continuity. The lesson encoded in ancient myths is not superstition, but humility. Human civilization rests on inherited knowledge layered over deep time. Much of that time remains obscured, not because it was empty, but because it was fragile. The Ice Age did not erase humanity's potential. It tested it. Those who passed the test did so by remembering enough to rebuild, even if they no longer remembered where that knowledge first came from. In the end, the gods of the ancient world may tell us less about the supernatural and more about survival. They are the echoes of people who knew how to endure collapse and pass something forward. In listening to those echoes, we are not uncovering lost divinity, but confronting the long, uneven continuity of human memory itself. By the time humanity entered the Holocene, the climate had settled into a rare equilibrium. Glaciers retreated to the poles, coastlines stabilized, and seasonal patterns became predictable enough to support long-term planning. This stability is often treated as the natural backdrop for civilization, but in reality, it was an exception. For tens of thousands of years before, rapid shifts had defined human experience. The calm that followed felt less like a beginning and more like relief after prolonged danger. This sense of relief shaped how early societies organized themselves. Having lived through instability, communities sought permanence. Stone replaced wood. Settlements anchored themselves to reliable water sources. Storage became central, not just for food, but for security against uncertainty. The architecture of the early Holocene reflects this mindset. Buildings were not only shelters, they were statements against transience. Agriculture, once established, intensified this drive. Fields required investment across seasons. Irrigation demanded coordination over years. Granaries represented trust in the future. Each of these choices assumed continuity, an assumption hard-earned after the Ice Age. Yet beneath this confidence lay memory. Stories of flood and fire did not disappear. They were integrated into ritual calendars, moral codes, and cosmologies that acknowledged both abundance and loss. This dual awareness appears clearly in early religious systems. Deities are often associated with cycles of death and rebirth. Creation myths are paired with destruction myths. The world is not made once, but many times. Such narratives reflect lived experience in a climate that had proven capable of ending worlds. Stability was celebrated, but impermanence was never forgotten. The archaeological record mirrors this tension. Early cities show impressive planning, but also signs of vulnerability. Flood defenses, elevated temples, and redundant food systems suggest societies acutely aware of environmental risk. These were not naive communities stumbling into complexity. They were cautious builders, informed by inherited memory. This is particularly evident in river civilizations. The Nile, Tigris, and Euphrates brought fertility, but also danger. Flooding could nourish fields or destroy settlements. Managing these rivers required continuous observation and adaptation. Early water management systems reveal an understanding that control was provisional. Ritual and governance evolved alongside engineering, reinforcing social cohesion in the face of uncertainty. The same pattern appears beyond the Near East. In the Indus Valley, cities were built with advanced drainage systems, emphasizing sanitation and flood control. In China, early agricultural societies developed methods to cope with unpredictable rivers. In the Andes, terraces stabilized slopes and conserved water. These innovations reflect local responses to shared challenges rooted in post-Ice Age environments. What distinguishes these societies is not that they mastered nature, but that they respected its volatility. Their myths warned against arrogance. Their monuments aligned with the sky, not to dominate it, but to understand timing. Their calendars tracked cycles that could not be controlled, only anticipated. This awareness may explain why early civilizations invested so heavily in memory. Writing, once developed, was used not only for administration, but for preservation. Laws, genealogies, and myths were recorded to anchor identity across generations. Writing reduced reliance on oral transmission, but it also froze interpretations, narrowing the fluidity of memory. As civilizations grew, this narrowing intensified. Administrative efficiency favored simplification. Complex, ambiguous memories of the past gave way to clearer narratives of origin and destiny. Over time, the Ice Age receded from living consciousness, replaced by more recent histories. What remained were fragments, a flood story here, a vanished age there. This forgetting was not deliberate, it was structural. As societies stabilized, The need to remember collapse diminished. Success breeds amnesia. Yet the foundations of civilization were laid by people who remembered instability intimately. Their caution shaped institutions that later generations took for granted. The Holocene, for all its apparent calm, has never been static. Droughts, floods, and cooling events punctuated its early centuries. Some early settlements failed. Others adapted. The archaeological record shows cycles of growth and abandonment even within this stable era. Civilization did not advance smoothly. It stumbled, recovered, and learned. This pattern reinforces the idea that progress is contingent. It depends on environmental conditions, social memory, and adaptability. When one of these falters, collapse becomes possible. The Ice Age taught humanity this lesson harshly. The Holocene allowed it to apply the lesson creatively. Modern perspectives often separate prehistory from history, as if they belong to different worlds. In reality, they are connected by continuity and rupture. The skills that built early cities were forged in Ice Age landscapes. The stories that warned of disaster were shaped by real loss. The calm of the Holocene did not erase this heritage. It rested upon it. Understanding this connection changes how we interpret early civilization. Instead of seeing sudden brilliance emerging from ignorance, we see resilience emerging from adversity. The achievements of the Holocene are impressive, not because they appeared quickly, but because they survived long enough to leave a record. This survival was never guaranteed. Many experiments failed. Many communities vanished. What we study today represents a narrow slice of what once existed. The deeper past remains obscured not by lack of complexity, but by the selective forces of preservation. In this sense, the Ice Age still shapes us. It set the conditions under which humanity learned flexibility, cooperation, and long-term thinking. These traits enabled survival during chaos and success during stability. They form the invisible inheritance beneath every city, every field, and every story we tell about our origins. The end of the Ice Age did not mark humanity's triumph over nature. It marked a temporary alignment between human capability and environmental possibility. Civilization arose not because the world became safe, but because it became just stable enough to remember what instability had taught. As memories of Ice Age collapse faded into myth, humanity entered a long experiment in permanence. Cities grew taller, populations denser, and systems more interconnected. The successes of the Holocene encouraged a belief that the world had stabilized for good, that catastrophe belonged to the distant past. Yet beneath this confidence, the same forces that once reshaped the planet continued to operate, slow but relentless, indifferent to human ambition. Geological records show that even during relatively stable periods, Earth's climate can shift abruptly. Ice cores reveal sudden temperature swings lasting decades rather than millennia. Sediment layers preserve evidence of rapid droughts, floods, and volcanic winters. These events did not end civilization, but they tested it. Each test left marks: abandoned cities, collapsed trade networks, and cultural resets that echo the deeper patterns of prehistory. One of the clearest examples comes from the Bronze Age collapse around 1200 BC. In a span of decades, major civilizations across the eastern Mediterranean fell into decline. Cities burned, writing systems disappeared, and long-distance trade collapsed. The causes remain debated, but climate stress, drought, and systemic fragility are central factors. What matters here is not the scale of the collapse, but its structure. Complex systems failed rapidly when multiple pressures converged. This pattern mirrors the end of the Ice Age in miniature. Stability bred complexity. Complexity bred dependence. Dependence reduced resilience. When stress arrived, recovery required simplification before rebuilding. The lesson is not that civilization is doomed, but that it is conditional. It flourishes within certain environmental and social bounds and falters when those bounds are exceeded. Ancient societies understood this intuitively. Their myths warned against excess and imbalance. Their rituals reenacted destruction to keep memory alive. Modern societies, by contrast, often separate knowledge from experience. We model climate change in data, not story. We track risk in probabilities, not myth. This increases precision, but it also weakens emotional engagement with long-term danger. The legacy of the Ice Age reminds us that abrupt change is not theoretical. It is historical. Sea levels rose by more than 100 meters in a few thousand years. Entire coastlines vanished. Ecosystems reorganized faster than cultures could adapt. These transformations did not require human influence. They emerged from natural processes amplified by feedback loops. Today, humanity has introduced a new variable into this system. The rapid release of greenhouse gases is altering atmospheric composition at a rate unmatched in the geological record of the Holocene. While orbital cycles still govern long-term climate trends, short-term forcing now operates on a human timescale. This does not recreate the Ice Age, but it increases instability within an already dynamic system. The danger lies not in gradual change, but in thresholds. Ice sheets, ocean currents, and ecosystems can absorb stress up to a point. Beyond that point, change accelerates. The Younger Dryas demonstrated how quickly climate can reverse direction when thresholds are crossed. Modern science recognizes similar risks in the weakening of major ocean circulation systems and the loss of polar ice. What makes this moment historically significant is that humanity now spans the globe. During the Ice Age, collapse was regional. Survivors could migrate, adapt, or merge with other groups. Today, systems are interconnected. Food production, energy, and information depend on global networks. This connectivity increases efficiency, but reduces isolation. When disruption occurs, it propagates. In this context, the ancient pattern of survival through memory becomes relevant again. Knowledge alone is insufficient if it is not integrated into culture. Data must translate into behavior. The stories we tell about our past shape how we prepare for the future. If history is framed as linear progress, warning signs are dismissed as anomalies. If history is understood as cyclical adaptation, caution becomes rational. The Ice Age offers a model of humility. It shows that intelligence and ingenuity do not guarantee control. They guarantee only the capacity to respond. Early humans survived not by mastering the planet, but by aligning with its rhythms, however imperfectly. They watched the sky, read the land, and adjusted when conditions changed. Modern civilization, for all its sophistication, still depends on these same fundamentals. Water, soil, temperature, and energy flows remain decisive. Technology can buffer change, but it cannot eliminate dependence. When systems fail, responses will echo ancient patterns: migration, simplification, and the reorganization of social structures. This does not imply inevitable collapse. It implies choice. Societies that recognize limits and preserve adaptability can navigate change more effectively. Those that assume permanence invite shock. The difference lies not in foresight alone, but in cultural orientation toward uncertainty. The deep past reveals that humanity has faced world-ending change before. It survived by remembering enough to rebuild, even when much was lost. That memory is encoded not just in myths or monuments, but in behavioral traits shaped by long struggle. Cooperation, storytelling, and long-term thinking emerged as survival strategies long before they became moral ideals. In revisiting the Ice Age, we are not indulging nostalgia or speculation. We are examining the conditions under which humanity learned to endure. The questions raised are not about lost golden ages, but about future resilience. What knowledge will survive disruption? What structures will prove adaptable? What stories will carry meaning when certainty dissolves? The Holocene's apparent calm may be ending, not in ice, but in volatility. The form of change differs, but the challenge is familiar. Humanity must once again balance innovation with restraint, growth with memory. The Ice Age teaches that survival does not belong to the strongest or the most advanced, but to those capable of adjusting when the ground shifts beneath them. Seen from this perspective, the past is not distant. It is instructional. It reminds us that civilization is an ongoing experiment conducted under changing conditions. Its success depends not on denying instability, but on integrating it into planning, culture, and identity. The end of the Ice Age was not the last test humanity faced. It was the first one we remember imperfectly. The next test will not erase the past, but it will determine how much of the present is carried forward. Whether memory once again becomes the bridge between worlds depends on what we choose to remember now. As the long arc of human history stretches from the Ice Age into the modern world, a subtle shift becomes visible. The farther societies move from the experience of collapse, the more abstract their understanding of risk becomes. Early communities remembered disaster through story, ritual, and place. Later civilizations recorded it in chronicles. Modern societies model it with equations. Each step increases precision, but also distance. What is gained in accuracy can be lost in urgency. In prehistoric and early historic cultures, memory was embodied. Flood stories were told beside rivers that had once overflowed. Ruins were built atop older ruins, visible reminders that cities could fall. Seasonal rituals marked survival through cycles that had once been unpredictable. These practices kept awareness alive not as data, but as lived meaning. The past was present because it was felt. Over time, this intimacy faded. As stability persisted, catastrophe was pushed further back in memory. Disasters became exceptional rather than expected. When societies no longer anticipate collapse, they design systems optimized for efficiency rather than resilience. Surplus replaces redundancy. Speed replaces adaptability. These choices work well under stable conditions, but they amplify vulnerability when conditions shift. History offers repeated examples. Civilizations often reach their greatest complexity shortly before disruption. Networks grow dense, dependencies multiply, and local failures cascade into systemic breakdown. This pattern does not require malice or ignorance. It emerges naturally when success obscures fragility. The Ice Age collapse was extreme, but the underlying dynamic is the same. What distinguishes the Ice Age transition is that it reshaped not only societies, but the baseline assumptions of human existence. Before it ended, humans lived with constant uncertainty. After it, they experienced a long interval where planning paid off. This shift encouraged confidence in permanence. Yet that confidence rests on conditions that are temporary on geological timescales. Modern climate science confirms this impermanence. Ice sheets respond slowly until they do not. Ocean currents appear stable until thresholds are crossed. Ecosystems absorb stress until feedback loops reverse their behavior. These nonlinear responses mirror what likely occurred during abrupt events like the Younger Dryas. The lesson is not that disaster is inevitable, but that change can accelerate unexpectedly. The challenge for contemporary societies is not a lack of information, it is integration. Data alone does not change behavior. For most of human history, behavior was shaped by narrative frameworks that linked action to survival. Myths encoded caution. Rituals reinforced restraint. Even when explanations were symbolic, their effect was practical. Relearning this integration does not mean abandoning science. It means reconnecting knowledge with meaning. Climate models must inform culture, not just policy. Risk must be communicated not only as probability, but as lived consequence. The Ice Age teaches that societies, which internalize uncertainty, adapt better than those that deny it. This perspective also reframes debates about progress. Advancement is often measured by accumulation, more energy, more production, more connectivity. Yet accumulation increases exposure when systems depend on constant throughput. Resilience, by contrast, values flexibility, diversity, and the ability to operate under constraint. These traits were essential during the Ice Age and remain relevant now. Ancient societies, constrained by environment, often built resilience unintentionally. They diversified food sources, maintained seasonal mobility, and embedded social cooperation into survival. Modern societies, freed from many constraints, must choose resilience deliberately. This requires acknowledging limits without framing them as failure. The deep past shows that humanity does not thrive by eliminating risk, but by negotiating with it. Ice Age peoples did not control climate. They adjusted to it. They accepted migration, loss, and change as part of existence. Their success lay in responsiveness rather than dominance. This mindset enabled survival through conditions far harsher than those faced today. At the same time, the past warns against romanticizing hardship. Many did not survive. Entire cultures vanished. Adaptation is not guaranteed. It depends on social cohesion, access to resources, and the capacity to learn. The memory of collapse is valuable precisely because it is costly. Forgetting it invites repetition. In modern contexts, forgetting often takes the form of short-term optimization. Economic systems reward immediate return. Political systems favor near-term stability. Long-term risk is discounted. This bias is understandable but dangerous. The Ice Age transition unfolded over centuries, yet its most disruptive moments were abrupt. Preparation mattered long before impact. This is where history becomes guidance, rather than curiosity. Studying the Ice Age is not about uncovering lost worlds for their own sake. It is about recognizing patterns that recur under different conditions. Environmental stress, social complexity, and memory interact to determine outcomes. Change the variables, and the pattern remains. The end of the Ice Age did not destroy humanity, it reshaped it. The societies that emerged afterward were not superior in essence, but better matched to new conditions. They carried forward fragments of knowledge, adapted them, and built systems suited to a warmer, more stable world. When stability wavers, the process repeats. Seen this way, civilization is not a monument, but a process. It is continuously rebuilt in response to shifting constraints. Its apparent solidity masks ongoing negotiation with forces beyond human control. The Ice Age reminds us that this negotiation is permanent, even when it fades from awareness. As the present era faces its own forms of instability, the value of deep memory becomes clear. Not memory as nostalgia, but memory as orientation. Knowing that change has come before, that collapse has been survived, and that recovery required humility rather than dominance can inform choices now. The Ice Age does not offer a blueprint for the future. It offers perspective. It shows that humanity's greatest strength is not technological prowess, but adaptability grounded in awareness of limits. When societies remember this, they endure. When they forget, history reminds them. In that sense, the most important legacy of the Ice Age is not what was lost, but what was learned under pressure and carried forward. That learning remains available, not buried under ice or sea, but embedded in the long, uneven story of how humans respond when the world changes faster than expected. When viewed from a great distance, human history appears continuous. One era flows into the next, technologies accumulate, populations expand, and knowledge compounds. But when examined closely, that continuity fractures. What survives is not everything, but enough. Enough memory, enough skill, enough structure to begin again. The Ice Age stands as the largest fracture humanity has yet endured, and the civilizations that followed it are not evidence of uninterrupted ascent, but of selective survival. This realization forces a reconsideration of what is meant by advancement. Complexity is often treated as a destination, as if once reached it remains secure. The deeper record suggests otherwise. Complexity is temporary. It requires energy, coordination, and environmental tolerance. When any of these fail, complexity simplifies. What remains are core functions that allow continuity to persist at a lower level until conditions permit expansion again. Throughout the Holocene, this pattern repeats. Societies rise, centralize, and specialize. Then stress arrives in the form of drought, cooling, flooding, or resource depletion. Administrative systems falter. Trade networks shrink. Populations disperse. Over time, new centers emerge, drawing on fragments of the old. Each cycle leaves behind both innovation and warning. The Ice Age transition magnifies this pattern to a planetary scale. It was not merely a collapse of individual societies, but a reconfiguration of the entire human environment relationship. Landscapes transformed, fauna vanished, sea levels rewrote geography. Any social systems tightly bound to the old conditions were rendered obsolete. Survival favored those who could detach identity from place and adapt practice to change. This adaptability shaped human cognition. Flexibility, storytelling, and long-term planning became evolutionary advantages. Groups that could imagine futures different from the present were better prepared for disruption. Myths of destruction and renewal are not passive memories. They are mental rehearsals, training societies to expect discontinuity and respond to it. As time passed and stability returned, these narratives lost urgency but not structure. They became cultural artifacts rather than survival manuals, yet their persistence hints at unresolved tension. Civilization thrives on the assumption that tomorrow will resemble today. Myth reminds us that this assumption has failed before. Modern society inherits both impulses. On one hand, it builds systems optimized for efficiency under stable conditions. On the other, it retains faint echoes of older caution, visible in disaster planning, redundancy, and cultural fascination with apocalyptic scenarios. These echoes are often dismissed as irrational, but they may represent inherited sensitivity to fragility. Technology complicates this inheritance. It extends reach and capability, but also increases interdependence. Systems grow larger and faster, amplifying both benefit and risk. A failure in one domain can cascade globally. This interconnectedness mirrors the vulnerabilities of ancient complex societies, scaled up to a planetary level. The Ice Age offers a lens through which to view this tension. It demonstrates that environmental change does not negotiate with social expectations. It operates according to physical processes indifferent to human values. Adaptation requires alignment, not assertion. Societies that attempt to override constraints eventually encounter limits. This does not diminish human agency. It clarifies it. Agency lies not in controlling outcomes, but in shaping responses. Early humans did not stop the ice from melting or the seas from rising. They chose where to move, how to reorganize, and what knowledge to preserve. Those choices determined which lineages endured. Preservation is therefore an active process. It involves selecting what matters under pressure. During the Ice Age transition, portable knowledge survived best. Skills that could travel, such as tool-making, navigation, and astronomical observation, endured. Fixed investments, like coastal settlements and specialized megafauna hunting strategies, were lost. This selective survival shapes what later civilizations inherit. It explains why certain forms of knowledge appear suddenly, while others vanish without trace. The archaeological record captures only what could be carried forward into new contexts. What was too tied to vanished environments disappears from view. Understanding this process reframes debates about forgotten chapters of history. The question is not whether humanity once reached modern levels of technology, but whether it explored diverse forms of complexity suited to different conditions. Some of those forms may have been effective within Ice Age environments, but irrelevant afterward. Their disappearance does not imply failure, only mismatch. The present era faces a similar challenge in reverse. Technologies optimized for stable conditions may become liabilities under volatility. Infrastructure built for predictable climates struggles with extremes. Systems designed for growth falter under scarcity. The lesson from the Ice Age is not to reject complexity, but to design it with adaptability in mind. Adaptability requires memory, not nostalgia for the past, but awareness of patterns. When societies recognize that collapse is part of history, they plan differently. They value redundancy over efficiency, diversity over uniformity, and resilience over speed. These values do not guarantee survival, but they improve odds. The deep past shows that humanity has repeatedly underestimated the speed at which conditions can change. The younger Dryas arrived abruptly. Sea level rise inundated landscapes within lifetimes. Megafauna vanished faster than cultural systems could adjust. Each event redefined what was possible. Yet humanity persisted. It persisted not because it predicted every change, but because it retained the capacity to respond creatively. This capacity is not tied to any specific technology. It is cultural. It depends on communication, cooperation, and the willingness to revise assumptions. Civilization, then, is not a permanent state achieved once. It is a recurring negotiation between human ambition and environmental reality. The Ice Age transition was the most dramatic instance of this negotiation. The civilizations that followed are products of compromise rather than conquest. Recognizing this lineage alters how the present is understood. Modern society is not the endpoint of progress, but the current configuration in a long sequence. Its stability is provisional. Its achievements are impressive, but conditional. What matters is not how much is built, but how much can be carried through disruption. The Ice Age leaves humanity with an unfinished instruction. It shows that worlds can end without malice and begin again without certainty. It shows that memory, not material accumulation, is the thread that links eras. And it suggests that the true measure of civilization is not its height at its peak, but its ability to leave something usable behind when conditions no longer support it. At the far edge of what we can reconstruct, history dissolves into probability. Stone erodes, coastlines vanish, and memory thins until only patterns remain. The Ice Age sits at that boundary, not as a single event, but as a long negotiation between humanity and a planet in motion. What survived that negotiation was not dominance, not certainty, but continuity carried through change. When the last glaciers withdrew and the Holocene began, humanity did not step into a blank world. It stepped into one shaped by loss. Landscapes had been rewritten. Species that once defined daily life were gone. Entire regions lay underwater. The people who lived in this new world carried invisible baggage, inherited caution, fragmented knowledge, and stories shaped by endings. Civilization did not arise in spite of this burden, but because of it. The early monuments, myths, and systems of order that followed the Ice Age were not expressions of naive optimism. They were responses to vulnerability. Stone was chosen because wood decays. Alignment with the sky mattered because the sky endured when land did not. Ritual mattered because it stabilized behavior across generations. These choices reflect a deep understanding that permanence is rare and must be constructed deliberately. Over time, that understanding faded. As centuries passed without existential disruption, stability became assumed rather than earned. Myths hardened into tradition. Tradition softened into culture. Culture eventually forgot its origins in survival. What began as memory became identity, and identity replaced caution. Yet the physical world never forgot. Orbital cycles continued. Oceans circulated heat. Ice advanced and retreated far from human sight. The same forces that once ended the Ice Age never stopped operating. They only paused in ways that allowed complexity to flourish temporarily. The story traced through this journey is not one of lost golden ages or hidden empires. It is the story of selective endurance. Humanity has always been capable of complexity. What it lacks is the ability to preserve all complexity through disruption. Each collapse trims excess, leaving behind what can travel, adapt, and recombine. This is why the past feels discontinuous. It is not because history resets, but because memory does. The written record begins late, not because nothing came before, but because writing requires stability. Before that stability, Knowledge survived in forms less durable than stone or ink. When those forms failed, so did visibility. Understanding this reframes how the deep past is judged. Absence of evidence is not emptiness. It is the signature of environments hostile to preservation. Ice, water, and time are not neutral archivists. They are editors, ruthless and selective. The Ice Age therefore stands as a filter rather than a wall. It filtered humanity's experiments with social organization, technology, and worldview. What passed through shaped the civilizations that followed. What did not pass through remains invisible, not because it never existed, but because it could not survive the conditions imposed upon it. This insight carries weight beyond academic debate. It speaks directly to the present. Modern civilization has achieved a level of complexity unmatched in scale. It also operates closer to environmental thresholds than any society before it. The question is not whether change will occur, but how much of what exists now can pass through it. History suggests that what survives will not be the most intricate systems, but the most adaptable ones. Knowledge that depends on fragile infrastructure is vulnerable. Knowledge that can be taught, remembered, and applied under constraint endures. The Ice Age favored such knowledge, and so may the future. This does not mean retreating into primitivism or fear. It means recognizing that resilience is an active design choice. It must be embedded into institutions, technologies, and cultural narratives. Societies that plan only for success inherit fragility. Societies that plan for disruption inherit options. The people who lived at the end of the Ice Age did not know they were standing at a turning point in human history. They only knew their world was changing faster than expected. They responded with movement, cooperation, and meaning-making. They told stories to preserve orientation when landmarks vanished. They built where they could. They adapted where they had to. Modern humanity is not so different. It possesses far more information, but it faces the same fundamental uncertainty. The Earth remains dynamic. Stability remains conditional. The future remains open. What the Ice Age ultimately reveals is not a secret past, but a persistent truth. Human history is not a straight line, nor a closed circle. It is a sequence of adaptations shaped by constraint. Each era believes itself exceptional until it encounters limits. The value of looking backward, then, is not to romanticize what was lost, but to understand what carried forward. Memory, flexibility, cooperation, and humility are the recurring traits that bridge endings and beginnings. They matter more than any single technology or monument. In the end, the Ice Age does not challenge the story of civilization by denying it. It deepens it. It reminds us that what we call history is the part that survived conditions harsh enough to erase most traces. It teaches that continuity is fragile, but possible. The world that existed before the last ice melted is gone. The people who lived there are gone. What remains is the pattern of how humanity responds when certainty collapses. That pattern is still unfolding. Civilization did not begin when the Ice Age ended. It resumed under new rules. And whether it endures again will depend not on how much is built, but on how well memory, adaptability, and restraint are carried into whatever world comes next.